Okay, chapter 4 is all about merchandising math. So basically, we're going to be taking the perspective of a retailer. So you're Best Buy, for argument's sake. Okay, you're the retailer. You have to buy products from a manufacturer or could be a distributor. So, oops, manufacturer. Okay, when you buy from the manufacturer kind of offers two types of discounts. There's a straight discount, maybe perhaps for volume, or because you're a regular customer, they give you a discount percentage. The other kind is for paying like a cash discount, or it regards to invoicing. So you get your invoice from them, and if you pay early, you get a discount. Okay, and that becomes the cost, of the product. So I buy a computer from HP, and maybe because I'm Best Buy, instead of paying $500 for it, I'm actually only paying $400. So I'm getting a discount. So I get 20% off. And then if I buy 100 of them, I get invoice for them. And if I pay early, then I'm going to end up getting a discount on that. So that becomes the cost for the retailer. And what happens is, from the retailer to the customer, oops, can't spell, there's a markup involved. Okay, you take your cost and you mark it up. And of course, when you mark up your products, you not only want to make money, but you have to cover your costs. So not just the cost of the product, but the cost of rent and utilities and salaries, etc. So that's where you have markup. Sometimes you mark up your product and you want to have a sale for whatever reason. So we're going to also do something called markup, markdown. So in other words, that's for a sale. So you charge a markup and product costs $100, and well, now you're trying to get rid of it because you only have 2 left. You're going to discount it. So that's called markdown. Okay, and then we're going to do a whole combination of things at the end of the chapter where we basically follow the product from the time it was purchased from the manufacturer all the way through to discounted for the retailer. The retailer marks it up to be sold to the customer, and at the end of the day, end of the month, they only have 1 left, so they discount it. Okay, so we're going to go through all that. We're going to look at the percentage rate, increase, markup, percentage markdown, etc. Okay, so that's just a little bit of an overview of what we're going to be doing this chapter. So 4.1 deals with trade discounts. In other words, your manufacturer sells their products to the retailer and gives them a trade discount. Okay, and the distributor, there may be a list price. Okay, so I'm using distributor and manufacturer interchangeably because sometimes retailers will buy right from the manufacturers. Sometimes they go through a distributor. They may have a list price for the item, but they're going to offer it to the retailer at a discount rate. Okay, or a wholesaler. Okay, so that's called a trade discount. And the resulting price after the discount is called the net price. So here we go, net price. So basically, your net price is whatever your list price is. Okay, so that's like the book value, the book price minus the trade discount. Okay, and if the discount is given as a percentage, okay, you use this formula N equals L times 1 minus D. So basically, if they're giving 20% off, so let's look at a quick little example here. If you're giving a 20% discount, so we have a 20% discount, and if the net price, for argument's sake, is, or not the net price, the list price, okay, is $100, okay, and the distributor is giving a 20% discount, then the net price that the retailer or the wholesaler, depending on, is going to pay is that $100 times 1 minus 0.20. So in other words, they're getting a 20% discount, which is 100 times 0.8, okay, or $80. Okay, so the net price to the retailer is $80. Okay, so that becomes, and we'll get into the costs, and that becomes their cost. So if I'm the retailer and I buy something for $100 and get a 20% discount because I'm a good customer, then my cost is going to be $80. So, and sometimes multiple discounts are offered. So the first discount might be because of the customer, and then the second discount might be because they're buying more than 100 units, that kind of thing. So basically, you would just you could use more than multiple, and you would, because it's a discount on a discount, in other words, it's compounding discounts, you would use the formula N equals L times, and then 1 minus D for the first discount times 1 minus D2 for the second discount, etc. Okay, so just like when we did the compounding interest and we multiplied all the interest rates, like the compounding interest together to get an equivalent or a overall compounding rate for 5 years, you can find the same thing for discount rates. An equivalent discount rate is a single discount rate that gives the same net price. So in other words, once I multiply them all together, I get a single discount rate that is equivalent to each individual one combined. So for example, if the net amount after applying 3 discounts to a list price of $100 is $74, then the amount of the discount is 100 minus 74 equals 26. So the equivalent discount rate, if you multiply 26, or put 26 over 100 and multiply by 100%, you get 26%. So the equivalent discount rate is 26%. So maybe it was a 10% discount, then a further 5%, then an 8%, or it doesn't add up to 26%, but because it's compounding, it becomes a bigger percent. I don't know if those are the right numbers, but that's just an example of it. Okay, so although the formula for net price is used in the context of trade discounts, it can really be used for any percentage off calculation. So, if you're at a store and they're giving 50% off, and then you have a coupon for a further 20% off of that 50%, it's the same thing. Okay, so the multiple discount formula can be used basically where that original list amount undergoes a series of compound percent decreases. Okay, so let's look at an example. Calculating the discount amount and net price when list price, is $995. The discount rate is 16 2/3. And I know how much everybody loves fractions. But in this case, we don't actually have to use the fraction. We can convert it because we're looking at a discount amount. So 16 2/3, is the same as 16.6667. Let's use lots of decimals here. Okay, that's percent. Okay, we have to now, in order to use that, have to convert that to a number. Okay, so 16.667% is the number 0.1666. How many sixes have I got? One more. Okay, I don't need that many, but 667. Okay, so let's put it in our formula. N equals L times 1 minus D. Okay, so we're given the list price, $995. Okay, 1 minus 0.66. Oh, 166. Okay, and if we get our calculators out here, we find out 1 minus 0.66. Oh, I keep doing that. 1 minus 0.1166667. Okay, is equal to 0.833333. I guess we don't need to keep quite that many decimals, but 995, because we're just going to round to a dollar value anyway. So $829.17. Okay, so you could probably get away with even just 1, 2, 3, 4. So yeah, you get slightly different answers. So the more decimals you keep, especially when you're dealing with a fraction that doesn't convert evenly, the more decimals you keep, the more accurate the actual answer. So in this case, our net amount, the net cost would be $829.17. Okay, let's look at the trade discount rate. So now we're actually going to calculate the trade discount rate when we're given a list price and we're given a net price. So again, we're using the same formula, N equals L, 1 minus D. This is where all that wonderful algebra that we learned came in handy. Okay, so we have a net price of $34.97. Our list price is $49.95, and we don't know D. We want to find out that discount rate. Okay, so we're going to have to make sure, because it's a rate, we'll have to convert it to percentages afterwards. So how do we solve? Okay, in order to solve, we need to get D by itself. So let's first we divide by what's in front of the 1 minus D, because that's a bracket. We can't just start subtracting anything yet because this is multiplication, right? Okay, so divide by 34.95 divided by the 49.95, and you get 0.7001 is equal to 1 minus D. Okay, so we want to solve for D. Remember, just like with compounding interest, the 1 represents your initial investment. In this case, the 1's representing what your list price would have been at minus your and then minus, you subtract off the discount. So we have to solve for D. So if we subtract 1 from both sides, because we want it to be, we want to have these two disappear. So 1 minus 1 is 0. We get negative 0.2999 is equal to negative D. Okay, so remember that's a negative D. So if we want D, we have to basically either divide by negative 1 or multiply by negative 1. So we end up with strictly D on this side. Because they're both negative, the positive version is 0.2999. Okay, so the discount rate, now we have to convert it to percentages, is 29.99%. Okay, or if you round that to an even number, which you can, it's 30%. It's actually probably 0.299999. So when you round to 2 decimal places, you get 30. It turns to 30%. Okay, so calculating the list price when the discount rate is 40% and the discount amount is $7.99. So in this case, we want to find L. So N equals L1 minus D. Well, the problem is we don't know the net price and we know the discount rate, so we're missing 2 pieces of information. So what else do we know? We know that the discount amount, okay, let's say we'll call that A for amount, okay, is equal to the list price minus the net price. Right? So you take, basically you're taking the difference between what the original list price is and what the actual net price is, and that we can find the list, or the amount, discount amount. So what does that tell us? What else do we know? The discount rate, okay, is going to, that discount rate D is a percentage. It's a percentage of the amount. Okay, so that whatever that amount is, in other words, how much am I getting off? Or in other words, what's how much is being taken off the list price? Okay, as a percentage of the original list price. So we know that this amount, so this is the difference, okay, is equal, when I take that as a percentage of my list price, I get my discount rate. So you don't forget, you got to multiply by 100 to get a percent, right? So that will give you your percentage. We know that the discount, the rate is 40%, okay? And we also know that we know the discount amount. We don't actually know the net price. I'm going to take the 100 out because we'll use real numbers rather than percentages. But you can use either way. So our discount amount is 40%. Our discount rate, pardon me, is 40%. Okay, and that's equal to the amount, so $7.99 over my list price, which is what we don't know. Okay, so now we have formulas we can work with. So these formulas it's important to understand what discount amount is, and that's basically the difference between list and net, and also how to figure that out as a percentage. Well, that amount is as a percentage of the list price is how much you're getting, what percentage you're getting off of the list price. Okay, so this is an important formula you need to know. Okay, so now we can solve for L. That was our whole point. So in other words, to solve for L, we have to get L out of the bottom, out of the basement. Okay, so we multiply both sides by L. We get 0.40 L is equal to 799. Okay, and now we can divide both sides by 0.40. Okay, and we're left with L equals $19.98. So if you took 40% off of the $19.98, and you can check this, right? You can check using your formula. Net equals L1 minus D. Okay, so your net is equal to $19.98 times 1 minus 0.40, which is $19.98 times 1 minus 0.40 is 0.6, and you get $11.99 or 98. Okay, so $11.99. Take the difference between the list and the net. So $19.98 minus $11.99 is equal to $7.99, which is your discount amount, which is what you were told at the top. Let's try another question. Calculating the list price when the discount amount is $258. So again, we know how much is discounted, and we know the net price. Okay, so just like we knew that the amount was equal to the list price minus the net, if you rearrange the formula, you can bring the n over to the other side, and you'll get that the list price is equal to the discount amount plus the net price. Okay, so this, we don't even need the percentage. We don't need to worry about using the percent, the n equals L times 1 minus D, because we can use this formula to figure out what the list price is, because that's what we're looking for. So list is equal to 258.75 plus the 891.25, and you add it up and you get $1,150. Okay, so a lot of these questions are with regards to a discount. 4.1, which is the trade discounts, is manipulating the formula, okay, and finding a variety of different, what given, list and per discount, what is the net, given net and discount, what is the list, that kind of thing.